Now we're going to be talking about exponential functions and their graphs. So here's an example of what an exponential function looks like. This is the parent function for exponential. It starts off really close to that x-axis and gets really tall really fast. It grows exponentially. The parent function looks like this. F of x equals a b to the x minus h plus k. This x minus h, that determines your left and right shift. This plus k determines your up and down shift. This a determines how much your graph is stretching or compressing. And then this b, we're going to start by just talking about when b is positive and greater than 1. And so that's when your graph is going to look like this. If b is a fraction between 0 and 1, then the graph is going to look a little different, but we'll get to that in a second. Another thing that might be new is something called the horizontal asymptote. That is a horizontal line that the graph approaches. It gets really close to, but it doesn't ever actually touch it. It's never going to cross it. It's just going to get really close to it, but never touch it. So when we're graphing these exponential functions, the first thing that we're going to do is make a table. We're going to pick some x values. We're going to substitute those into our equation and figure out what the y value would be. Then we're going to plot those points, figure out our horizontal asymptote, and determine the domain and range. So our first example is y equals 4 to the x plus 2. The first thing I'm going to do is just pick some x values. You can pick whatever x values you want. So let's just do -1, 0, 1, and 2. Now I'm going to substitute these x values into my equation. So 4 to the power of -1, 4 to the -1, is the same thing as 1 over 4, and then that's 0.25. So 1 over 4 plus 2 would be 2.25. Then if we substitute 0, 4 to the 0 is 1, 1 plus 2 is 3. Substitute 1, 4 to the 1 is 4, plus 2 is 6. And then if we have room, we can substitute in 2. 4 to the 2 is 16, plus 2 is 18. It doesn't look like we'll have room for that on our graph, but I wanted to go ahead and mention that. So, if x is -1, our y is 2.25, so I'm going to go up 2 and a little bit, in between 2 and 3, closer to 2. Then we've got the point 0, 3, and 1, 6. So those are just 3 of our points. Now to figure out the horizontal asymptote, we're going to look at this number that's at the very end. That's our k value. That is our horizontal asymptote, and since it's horizontal, it's going to be y equal to a number, and we're going to keep that number exactly as it is. Y is equal to 2. So for this horizontal asymptote, I'm going to put a dashed line at y is equal to 2. Again, that's the line that we are going to get really close to, but never actually touch. No point, no x value in this graph should ever get us a y value of 2. So that means that when I'm graphing it, I'm going to get really close to my horizontal asymptote, but never actually touch it. So I'm going to start off really close to it, and then I'm going to start going through these points that I have, and this is going up really quickly. Our domain here from left to right is all real numbers. Then our range, this graph is getting really close to 2 but never actually touching it, so that's why we're going to use open parentheses, and then it's going up forever, so we're going towards infinity. If we were ever to touch this line at 2, then we would use a bracket, but since we're never going to touch it, but we are going to get super duper close to it, we might get to like 2.0001, but not actually 2, we're going to use those parentheses.